A major train station can swallow enough electricity each day to light up more than 5,000 homes. Take London's Waterloo station. It burns through 250,000 kilowatt hours daily, while an average home sips just 30. And where does all that power come from? Often it's fossil fuels, with over 80% of the world's electricity still dug up or burned. The environmental cost is frankly alarming. One big station can pump out 15,000 tons of CO2 every year. That's the same as 3,000 cars chugging along for 12 months. This insatiable hunger for energy not only drains cash, but also fuels climate change. Just lighting those massive concourses alone needs millions of kilowatt hours annually. Then there's the heating and cooling for sprawling station areas, using 700,000 kilowatt hours yearly just to keep the temperature stable. Escalators and elevators, shuttling countless people, collectively suck up another 250,000 kilowatt hours per year. For one station, this massive energy bill is like powering a small town of 2,000 homes for an entire year. Add in the retail shops, ticket machines, and those giant digital screens, and you're looking at another 15% on top of everything else. Even the essential stuff like signal boxes and track heating needs juice 24/7, all year round. All this adds up to millions in electricity costs annually. It's creepy when you realize many of these stations were built with zero thought for sustainability. And with passenger numbers set to jump by 50% by 2050, this energy challenge is only going to get bigger. Cities are rethinking train stations, aiming for over 50% self-sufficiency to meet massive energy demands. This called for a radical redesign of urban transit hubs. London's Blackfriars Station now stands as a prime example, integrating enormous renewable energy solutions. Its iconic roof, a 6,000 square meter engineering feat, hosts 4,400 photovoltaic panels. Together, they supply over half the station's total electricity needs. That's like a small office building powering its own operations. This signifies a major shift in urban energy independence. The ambitious goal? Transit stations generating more than 50% of their own power. The strategy involves weaving in solar panels, geothermal systems, and even kinetic floor tiles. Stations, typically huge energy consumers, are now designed to generate, offsetting their 5,000 MWh annual grid draw. Imagine a massive transport hub, easily the size of an airline terminal, actively creating its own electricity. The hurdles were significant. How do you install thousands of modern solar cells on a century-old structure without stopping critical train services? Blackfriars Station in London proved it was possible. Its roof now supports 4,400 solar photovoltaic panels across 4,400 square meters. Each panel acts as a miniature power generator. This extensive system produces 900,000 kilowatt hours every year, enough to power 300 typical British homes. It's like an apartment building drawing all its energy from its neighbor's rooftop. This generated electricity directly cuts Blackfriars' substantial energy use for lighting, ventilation, and its 50 daily escalators. The outcome is a yearly reduction of 513 tons in CO2 emissions, a concrete move towards net zero infrastructure. If you find this engineering impressive, consider subscribing to Urban Rise. Transforming a massive train station into an energy powerhouse generating over half its own needs hinges on sheer scale. One cutting-edge station deploys 8,000 high-efficiency solar panels spread across 15,000 square meters, an area roughly matching 2 football pitches, all positioned for optimal sunlight. Beneath the surface, a 200-meter-deep geothermal system taps into stable underground heat. Imagine digging down the equivalent of 65 residential stories just for heating. Adding to this, 500 kinetic energy floor tiles capture the footsteps of millions of daily commuters, with each tile generating up to 7 watts per step, turning mere movement into usable power. Beyond electricity, sophisticated rainwater harvesting systems collect 20,000 liters each day for non-potable uses, significantly lowering demand on municipal water. A smart grid then orchestrates these varied sources, storing surplus energy in 2-megawatt battery banks, enough to power 2,000 homes for an hour. Blackfriars Station in London perfectly embodies this forward-thinking strategy. It features the world's largest solar bridge with a 200-meter-deep geothermal system plunging beneath it, comparable to stacking two Big Bens underground. Its iconic solar bridge incorporates 4,400 photovoltaic panels directly into its roof, spanning 4,400 square meters. These panels alone generate enough electricity to power 300 average UK homes annually, essentially creating an urban energy farm. This geothermal system delivers consistent heating and cooling, slashing conventional energy consumption throughout the year. Some stations now incorporate kinetic tiles that turn footsteps into 7 watts, enough to fully charge 2 smartphones at once. An advanced energy management system meticulously monitors 10,000 data points every second, precisely optimizing power distribution. Integrating these complex systems presented enormous logistical challenges, especially with ongoing train operations serving 100,000 passengers daily. At Blackfriars, a green transformation is slashing CO2 emissions by 513 tons a year. That's the same as removing 1,000 cars from London's busy streets. Operationally, the station is pocketing $1.5 million annually in savings, a number that might make facility managers question their life choices. Its energy contribution also offers up to 10% peak shaving for the local grid, keeping the lights on during those high-demand moments. This entire shift dramatically cuts down reliance on electricity generated by fossil fuels, directly helping London meet its ambitious 2030 sustainability targets. Blackfriars' success story has already sparked over 50 similar projects worldwide, impacting energy use for a staggering 200 million urban commuters. And it's not just good for the planet. The project generated 2,000 construction jobs and continues to support hundreds more in maintenance, proving green infrastructure can be a real economic powerhouse. They're even collecting 500,000 liters of rainwater each year, enough to fill 2 Olympic swimming pools for flushing toilets and watering plants. Looking ahead, there are plans to add another 2,000 solar panels and investigate systems that regenerate power directly from the trains. Real-time data from 20,000 sensors constantly fine-tunes performance, saving enough energy to power 500 average UK homes. This self-sufficiency makes the station far more resilient, able to maintain essential services for up to 48 hours even if the main grid fails. The initial investment was £100 million, but projections show a full return within 25 years. It's a powerful example influencing urban planners all over Europe, showing us what's possible when transport hubs become distributed energy plants. Blackfriars is offering a real-world blueprint for sustainable infrastructure projects everywhere. By 2030, over 100 major train stations worldwide are projected to achieve 50% energy self-sufficiency. The success of these pioneering self-powered stations is more than an engineering triumph. It's a profound statement about our collective future. These stations serve as living blueprints for sustainable city infrastructure, their success critical for over 56% of the world's population living in urban areas. Early adopters, like Blackfriars Station in London, have inspired projects across 15 countries, including Germany's Stuttgart 21 and New York's Moynihan Train Hall. Their impact extends beyond power generation, fostering resilience in our energy grids by reducing demand spikes by up to 30%, stabilizing local power supplies. Imagine a station producing energy equivalent to powering 1,200 average homes. Your smart home barely manages a few light bulbs. This is next level. This self-sufficiency significantly reduces operational costs, freeing up capital for further green investments. An estimated $1.5 billion USD saved globally by 2030. Innovation continues. Future stations may incorporate advanced geothermal systems reaching 500 meters deep or kinetic energy capture from passenger foot traffic. These stations are not just transit hubs, they are community anchors, driving local economies and creating jobs. One station can support over 500 local businesses. The environmental legacy is profound. Blackfriars Station alone offsets 513 tons of CO2 annually. That's equivalent to removing 300 cars from the road. The commitment to sustainability extends to water management, with some stations collecting 1 million liters of rainwater annually for reuse. That's a lot of flushes. Policymakers worldwide are now looking to these pioneers, enacting regulations and offering incentives. Over 20 cities have updated building codes by 2024.